So something like this. Projectile was here. Yes. Okay. So meron siyang may angle. May initial velocity. Okay. Sige, 40 degrees ang theta. 12 meters per second ang V naught. Then we have a height of, bigay tayo ng height. Let's say the height is 5 meters. We look for 3. Y max. Then we look for hang time and range. Okay? Okay, so let's do it. Now, step 1 is to get the components of our vector. Let's write everything that we know. Sa vertical muna tayo, no? Since y max ang ating unahin. Y would be negative 5 meters. 5 meters pala muna, sorry. 5 meters yung y natin dito. Then V naught y would be V naught sine theta. Vy equals, since peak height tayo, 0 at y max. Though G is negative 9.8 meters per second. Then time is not given. So, ang hinahanap natin dito ay y max. Looking for y max. So, hindi given ng time. So, ang gagamitin natin ay equation 3. Equation 3 is v squared equals v naught squared plus 2g delta y. In our case, delta y would be y max again. Okay, don't be confused. Hindi natin gagamitin yung 5 meters. We will not make use of that 5 meters na height nung hill. Why? Bakit hindi natin yung gagamitin? Because the ball was launched at a different height. So what we are trying to describe is the peak height from the launch point yun, hanggang doon sa peak height. So the height from the launch point up to that position, peak height. Okay? So hindi muna natin gagamitin yung 5 meters. Gagamitin natin yan mamaya pagka na-compute na natin yung displacement or yung vertical displacement niya galing dun sa launch point. Okay. Ano nga ba gagawin natin? Yeah. We would now be substituting using this equation delta y from launch to peak. So it will be v squared minus v naught squared vy. Lagyan natin ng y para alam natin na vertical. 2g. So at peak height, 0 yung ating final minus our initial velocity, 12. So sine 40, 7.71 meters per second. Divided by 2 times negative 9.8 meters per second squared. And we get 0.39 meters. So that is delta y from LP or from this point up to this point. what do we do next? Using this calculated height, we add it with the height of the platform. So this is what we will be doing. It will become y max equals delta y plus delta y LP. So this becomes 5 meters plus 0.39 meters. Y max will be at 5.39 meters. 5.39 meters ang ating Y max. Next is determining yung time natin from launch to, so this will be a two-part process again for time. So we will be determining the time from launch to peak and then from peak to the ground para dun sa pagko-compute naman nung range later. Let's do the launch point to peak height time. So yung time from launch to peak, we don't know that. But from launch to peak, we know that the initial velocity in y is 7.71 meters per second. Vy at peak, 0 at peak, and then g is negative 9.8 meters per second squared. Delta y, or y max, in this case, we will be using 0.39 because we are describing the motion from the launch to the peak. So it is 0.39 meters. So we can simply use equation 1 then. Let's just derive. So Vy equals V naught y plus GT. If we derive the equation to be used, it will become T is equal to Vy minus V naught y over G, which is equal to 0 minus 7.71 meters per second divided by negative 9.8 meters per second squared. T equals 0.79 seconds. So this is the time from launch to peak. At this point, so already we have 7.79 seconds that have passed. Okay? So what we will be describing next is the time from the peak height to the ground. So what do we know about the situations at the peak? Papunta sa peak, going to the ground, we should know that the initial velocity from the peak is 0. So V naught y, the initial vertical velocity at the peak, is 0. This time, instead of using 0.39 meters for your height, we will take into account the height of the launch point. Therefore, ang gagamitin natin would be yung y max na. So that is 5.39 meters. So still G would be negative 9.8 meters per second squared, and then time yung ating hinahanap. There is no mention of the final velocity, so we say that it is not given. We will make use of equation 2, and that will be delta y, which is again y max equals V naught t plus 1/2 GT squared. 1/2 GT squared. Now since V naught y is 0, then this term here can just be cancelled out. And we are left with y max is equal to 1/2 GT squared. Know where this is going. It becomes T is equal to, na ano na naman natin to kanina. We were able to, what do you call this? Solve for this earlier. So this becomes now 2 y max over G. So time from peak to ground would be given by this equation. I mean this equation. So we have 2 times 5 point, what is that again? 5.39 meters. 39 meters divided by negative 9.8 meters per second. Sorry. Yung ating dito should be negative. Since the object is displaced from the peak to the ground. So it should be negative. Second square. 1.05 seconds. And that is the time from peak to the ground. Let me rewrite. So we already know that the time from here from the launch point going to the peak, we already know that time would be equal to, how many seconds was that? 0.79 seconds. And then, from the peak going to the ground, we have time equal to 1.05 seconds. To get the total time, we simply add time from launch to ground would be equal to 1.84 seconds. Okay. So total time, let's go back to this, is 1.84 seconds. Now, we can finally solve for the range. We can solve for the range now. Delta x would be equal to, we don't know, V naught x would be equal to V naught cosine theta. Then t would be the time from the launch point to the ground, which is 1.84 seconds. First calculate, 12 cosine theta is 9.19 meters per second. To find x or delta x, the range, we know that horizontal motion is constant in projectiles. Therefore, we can treat 9.19 meters per second as the average velocity in the x direction. We can use the formula. We can use the formula V equals delta x over t. Simple algebra would tell us that it would be delta x equals average velocity times time, which is 9.19 meters per second times 1.84 seconds. Cancel time. Then we end up with 16.91 meters for our range. So it means that the distance from the launch point up to this end point here is 16.91 meters.